Roberto is a scientist from Italy, and a geologist, and he's talking about physics again.
So, in this second presentation, we are discussing methods, methodologies on how to quantify, to measure this Orgone energy. We will see is important. It's extremely important to know how much Orgone energy is available in a certain place, inside a certain instrument, orgone accumulator, or emitted by other instruments, the blanket, or emitted by or liquids or solids. So it's extremely important to know, to quantify the amount of energy available in a certain point. As far as nowadays, there is no a particular science based that is doing this, and so everyone is doing its own subjective evaluation of the field and of the amount available. It seems to me very high, it seems to me very low, no, it's medium, and so on. No one knows exactly, there is no standard. And it is mandatory for me, to me, but in general, for orgonomy to improve. Otherwise, it remains only an anecdotal science, to be able to measure an amount of Orgone energy in a standardized way. So now we are going to see an historical background, of what has been done in the last decades, first by Reich and then by other researchers, and then we will focus on what is available today regarding the methodology of measurements. So first efforts were done by Reich, because he soon understood that standardization of the measurement and the measurement itself were of extreme importance, extremely important, in order to allow orgonomy to improve and to go on ahead. Reich developed some methodologies that could measure both the differential energy concentration, differential between an organotic system and the environment, the outside environment, for instance, or the orgone field energy irradiated by an organotic system. So an organotic field that the system is radiating until to a certain distance. This is very important. This is very important because knowing the amount of Orgone energy or the particles we can also speak of units, particle, because the continuum in my take, but also in Reich's take, is made of particles connected to each other. Is very important because of paramount importance in that its concentration versus the time, the time of the day, the weather, the seasons, and other variables can be monitored and may have numerous several practical applications in all fields of science. An example, a very simple easy example, in the treatment of a disease, subjecting a patient to a known amount of energy, of orgone energy, such as the one available inside an aura core emitted by a blanket or so on, might allow a better understanding of the patient's response to the treatment, and at the same time, a better planning of future treatment. So this is mandatory, but this one is just an example of many, I would say infinite applications of this energy, but we know how much is there. Otherwise, okay. I would like to open a parenthesis because related to what has been said this morning. Related to the three phases of the energy, we know that the energy is in dynamic flow, is in Orgone state, and is indoor. Reich, when developing this type of methods, never spoke about Orgone or Ordor. So it is supposed that the methods that Reich developed at that time were aimed at measuring the dynamic flow. They were developed in the 40s. Orgone experiment was done in the 50s. So possibly he didn't know Orgone or Endor, or maybe he wanted to avoid the terms, the two states, and focusing only the dynamic flow of dynamic organ. Okay. He developed 4 different methodologies of measurements. The first one is based on the variation of temperature. T0 minus T is well known, T0 delta T, between a reference organ accumulator in ORAC of a fixed volume, 1 cubic feet, and the external environment. So in this case, you get a differential between the external environment and the ORAC. And the unit of measurement is org. But we will see, because just a listing now, and then I will go more in detail on of each measurement. Variation of the electroscope discharge rate between the inside of an organotic system, an ORAC for instance, and the outside environment. The obtained value gave the organ tension, according to Reich, or the orgonomy potential OP in hour per org between the two systems. In this case, it's clear, is a differential value. A differential value is a relative value between a reference one and another one. Then developed a further methodology to measure organ energy, this time focused to measure the radiation, the energy radiated by a living organism, a liquid, a substance, or a solid substance, but Reich focused above all on living organisms, not liquid or substance, mainly on living organisms. And the device that he developed was the field meter. A fourth methodology focusing only on liquid substances. Liquid substances are emitting fluorescence, and Reich was thinking that fluorescence was directly correlated, directly proportional to the organ content of that substance. So this type of measurement was conceived only for the liquids. And he obtained the organotic potency of the substance. Delta T, variation of temperature between a reference ORAC in the figure and the external environment. You have 2 thermometers, of course, one located here at the top of inside the ORAC, but at the top, and other at the same height externally. The difference between the two values gives the variation of temperature. But the amount of energy is not given by delta T, as many are thinking, but is given by this formula. That is delta T, T0 minus T, you can see here the different parameters, times the duration of the measurement times the volume of the organotic system of reference, 1 cubic feet in this case. And in this case, you can determine the amount of organ energy in org in a system related to another system. A relative value, a relative measurement. Was never developed this type of measurement because it's too difficult to apply, and was only for the records, as only an historical value, this one. Next one, yes?
So does this mean that the orgone energy is constant?
No.
That the total is
No,
constant?
no. Back. Duration depending on U. F a cube depending on the reference system is constant. So this one is a variable, and T0 minus T can vary in function of the environment, the weather, or
Yes.
the time of the day, and so on. Yes?
Then capital T equals duration of the measure. There's a small t in the formula.
What?
There's a small.
This one is temperature, this one is time.
Okay, and you used a capital T though.
Oh, I'm sorry. It's a mistake. Sorry. T small. Small t is time. Sorry. Duration in hour. Sorry. Discharge rate in an electroscope. It measures the orgone tension or the orgonomic potential OP by charging the electroscope here by rubbing a polystyrene or rubber rod or a cellulose or plastic disc, and then you put the rod here, and there is a leaf here that is moving upward in this way. In this way, this is half of the measurement because of the protocol. In this way, when the leaf is here, the leaf is moving slowly down to the vertical position. And the velocity, the rate of this movement from horizontal to vertical position is directly proportional of the orgone energy of the environment. The higher the orgone energy in the environment, the lower the velocity of a discharge. The higher the time the leaf it requires to move down. And for reference, in general, you don't wait, Reich, never wait it for the total discharge, but consider it only the discharge between the 10th and the 8th division, or the 4th and the 5th. It took this division as the reference. Next.
But that's metaphorical of where you live as a society, right?
Sorry?
Because it's if each of us is a leaf and
Okay.
we're disintegrated, the environment influences the individual's orgone energy.
Okay, but you can also use the electroscope to measure the radiation, the energy you radiate, for instance. You charge the electroscope, you put it close to your body, and you observe the discharge, repeating the measure far from your body, and you make a comparison. That's it.
Could this be done organ-wise,
Yes.
like over the organs?
No, I don't know. Maybe. I presume.
But over the organs.
Yes, of course. But no. Okay, over the organs, there is another methodology that we will see later at the end of the presentation. It can be done. What you are saying is it can be done by this type of devices, not this one, but another one, but a little bit different. We will see it at the end of the presentation. Last slides we have. Next. So the electroscope can give the orgone tension, the orgonomic potential of the orgonomic potential that is given by this formula. Orgonomic potential is given by T, the discharge rate in hour, and E0 minus ER, that are the two, or the difference between considering this division and the 10th and the 8th division is the condition between the passage, the moving between this division to this one. Or in other words, Reich considered the movement from the 10th to the 8th one. From the 10th to the 8th one, and this was given equal to 120 volts. Why? Because the total discharge, when you charge an electroscope to the maximum height, horizontal level, for the traditional physics, this corresponds to a potential, the electrical potential of 600 630 volt. If you divide more or less by 10 and consider two divisions, you get 120 volt. So, in other words, the discharge between this division to this one corresponds to a time, but corresponds also to 120 volt. And this time is changing according to amount of energy in the environment. So the lower the content, the lower the seconds, the hours, or whatever it is, the unit you are going to use, that it takes to go down. It's clear? Okay. So it's a question, simple equation that can be used to determine the orgonomic potential. For instance, if we consider the scale from 10 to 8, and the leaf, hypothetically, is discharging in 1 hour from 10 to 8, hypothetically, just a theoretical value, we can have the orgonomic potential will be 1 over 1 hour per org. But we know that the two division discharge correspond to 120 volt, or this one, and then I have that my environment, the energy content of my environment is I have an orgonomic potential that is discharging in 30 seconds 1 volt of electric potential. So here, Reich was able to find a correlation between the orgone potentials, orgone energy potential, and the potential of the mainstream physics, electrical potential. And, sorry, you wanted to ask? Okay, okay. And this one is very important because important type of measurement, because Reich said this one is a scheme of an electroscope, but he said that the electroscope was the measurement of the instrument of choice for the measurement of orgone energy, and not the voltmeter. Voltmeter was used for measuring secondary energy, electromagnetism, electricity, but the electroscope was the instrument of choice for measuring orgone energy compounds, and can be related in this way, because we simply know that this scale is equals to 630 volt of the mainstream physics, only for this, because otherwise you couldn't do this type of comparison. Next. An example here of this measurement, we have some data here taken by the electroscope according to that equation formula, according to the timing of the date, hour, and in minute per org, not in hour per org, but in minute per org. And he observed that the maximum value corresponded in clear days here around 4 p.m. Around 4 p.m. And the maximum values in the range between 10 and I don't know, 10 and
8 p.m.
Maybe here, yes, 8 p.m. Before and after this timing, the values were much lower in clear days. So it is a bell-shaped curve, for instance, and giving an idea of the energy of the environment, in this case, in those days. In cloudy days or rainy days, the bell-shaped behavior is flattening. So it means that there is less energy in the environment in the place of the measurement. The place of the measurement. Where you measure, if you are at the ground, it is a value corresponding to the orgone energy at the ground. If you are at 5,000 meters of elevation, it corresponds to the energy available at that altitude.
What's the flat one?
Oh, Oof, back, please.
Thunder shower.
During a storm,
Rainstorm.
during rain. There is no, practically the electroscope didn't work because
Water takes-
theoretically there is no energy or very low amount of energy in those conditions, in those weather conditions.
When water. Itself, and so the atmosphere doesn't have
Next.
energy pressure in it.
Another case is this one. Using the electroscope, he measured the orgonomic potential, orgon tension inside an accumulator, inside the room in which the accumulator was located, and in the external environment outside the room. You see that maximum value of energy, the potential, is given by the accumulator, inside the accumulator. The room is characterized by a lower value, the environment, again, lower than the other two values. He made also a comparison between T0 minus T, and he found that there is a parallelism between the two methods of measurements, two ways of measuring. Next. And this one is just taken from one of his books, electroscope. I presume this one is another electroscope modified, vacuum tube to measure in the energy here versus time and versus weather condition. Next. Third methodology developed by Reich was based on the fluorescence. So he considered this method because he was thinking that fluorescence could be considered a variable proportional to the organometric content of the system, but only for liquid in this way. Only for liquid. So, doing some measurements, he observed that if you put the organometric potency of distilled water 1, all the other fluid can be related, could be related to the distilled water. And he observed that rainwater was more than the distilled water, tap water more, seawater, etc. He made a lot of measurement by considering different fluids. For instance, here we have a broth and 50% calcium chloride gives 60, means 60 times the potential, the energy content of water. More than 100 is not pasteurized milk, etc., etc. So, is a way, just only for liquid, to determine the relative amount, relative, not absolute, relative to distilled water, of many other fluids. Biome water, for instance, Earth biome here is about 50. You start from distilled water 1, you do biome water, and then you are 50 times energy of the original fluid, distilled water. Next. A fourth method is the energy field meter. Everybody knows this, and is the most known, and also today is the only one available today. Is evaluating the intensity of the orgone field irradiated by living organisms. This method, however, can be applied also to liquids, solids, any substance available in nature. Yes.
It's being radiated. That means
Irradiated.
Out.
The field, the orgone field.
Because irradiated means being exposed. Something is radiated.
Okay. Okay.
Feel radiated.
Radiated.
Correct.
When you read irradiated, you should understand radiated. Okay, my fault. Sorry. Okay, radiated, or anyway, in other words, the orgone field of a substance could be living organism or a liquid fluid, and so on. Just a few lines regarding the structure, but is not so important. The structure is this one, is practically two sides of an orgone accumulator: metal Above we have an organic substance. Below we have another organic substance. The plate is connected to a Tesla coil. The two metallic plates are connected to a bulb. And then this sensor is transforming the light, possibly emitted by the bulb, in current, and you measure the current. That's it. This one is the field meter. And it did many experiments by using this scheme, this structure. One of these is this one. He used a tube filled with gas argon, fluorescent tube, held by hand and approaching the tube to the plate, to the two metal plate, it illuminated. And the bulb also illuminated as well. So it illuminated and giving light to the bulb that could be measured, the intensity of the light could be measured and transformed, converted in electricity. So you can compare the energy, in this case, emitted by whatever substance you consider. Your hands, when you approach your hands to the metal plate, the light, the bulb lighted, emitted. More intense were your approaching to the metal plates, and the higher was the light emitted by the bulb. A flashy cut bulb put on the with the leaf, on the same plates, gave a lighting, resulted in a lighting of the bulb. A live fish produced the same phenomenon. That fish instead produced initially a lighting of the bulb, but the lighting faded, vanished versus time, versus days. Again, a dry piece of wood didn't produce any light. Next. Next. Nowadays, next. Today, presently, this instrument is the only one available. The other three, conceived by Reich, are no longer available. I don't know why, probably because they were difficult to use. The electroscope was not so difficult to use, but the energy field meter could be used also to measure orgone energy inside the closed system, closed organotic system, for instance, an orgone accumulator. So it could be replaced, the electroscope, by the orgone energy field meter in all conditions. There is no, but the electroscope is an interesting instrument to use in measuring orgone energy content. This one is an apparatus, a device conceived in the 1970s by physicist, Swiss physicist Stark, and commercialized by the Swiss company Marat. But production of the device, manufacturing of the device, was discontinued after a few years. So you don't find many apparatuses around the world. This one is mine, I have. And it's a good apparatus, in my opinion, but I don't know why it was discontinued. The instrument measures the orgone energy concentration both in open and closed environments, organotic system, open and closed organotic system environment, as well as the orgone field radiated by liquid, and sorry, okay, it happens sometimes, and living organism. Okay. The working principle, I am not going inside this, but is measuring the Lorentz force, sorry, and the Lorentz force that is given by this formula. It requires a magnetic flux, or also called Oersted flux, in motion, in movements. And this one is the velocity of the movement on the magnetic flow. If you don't have movement of the magnetic flow, the Lorentz force is 0. So this is the limitation, the only limitation of the instrument. Otherwise, a very good, in my opinion, instrument. Okay, just it's telling how it's built and so on. Just okay. And okay, it could measure very low amount of orgone energy of the order of some picoampere. Okay, this one is the related electricity, but very low orgone energy content. This one could be used for forecast in support to the meteorology, in forecasting weather condition, could predict extreme weather condition 24 hours before the occurrence or the magnitude of an earthquake. It could predict night frost or the arrival of snow. All this could be forecasted, all these phenomena could be forecasted by this instrument. This one is an example. Snow, there is a high increase of the energy measured by the instrument, and the snow started here, and then the energy decreased. Some hours that is given here, some, in this case, 6 hours before. This one is the frost. Night frost is very high, the energy recorded by the instrument is going up. And then when it occurred, the energy of the environment is going down and down and down. And so on for other weather conditions, storms, and so on, etc., etc. Stark developed also a second instrument. This second instrument, that he called fluidometer, was conceived to measure the whole range of orgone energy amount, concentration available in nature. From the very small, the smallest, to the highest that he found were emanated by magnetic healers or Filipino spiritual healers. And this is the ratio, of course, from 1 to 10 over 12. So a very, very, very large range of bioenergetic content. This one is an example of energy emitted by the hands of a healer, by the FOF, by thinking something, it emits energy, or by the eyes. Unfortunately, it's no longer available. It was discontinued after a few years. It's no longer available, this one.
Do you have any of these instruments?
I have one. This one, the picture is the picture of the one I have. Yeah. Okay, today the only available. How many minutes I have?
Done. Give it a minute.
I am half of the presentation.
Yeah.
It's okay? Okay. The only instrument available today is the LM4 instrument. The LM4 instrument is produced by the Canadian company Heliognosis since September 2013. This one is based conceptually to the instrument, the field meter developed by Reich at the time. The engineer, owner of the Heliognosis, changed just a few things, small parts, in order to replace the bulb and the electric eye, and was replaced, these two things, by this one, a frequency electric field unipolarly connected via etc., etc. So, okay.
Do you have many slides left? Because we should be done.
He said he's half on it. He said he's half of the presentation. He said he's halfway of the presentation.
Alternating current sensor.
That's what he said.
Roberto, it's not possible. If you're halfway through the presentation itself, am I missing a time?
Are you?
Okay, I'm going a little fast. Okay. No, okay.
We won't have any time left
Okay.
for anybody else.
This one is an example. Okay, I'm going.
1:30, Armando is supposed to speak at 1:30. Continues for now.
How many minutes I have?
I finished.
5 minutes. Okay, 5 minutes. Okay. Okay, this one is the instrument. Okay. It consists of 5 scales that can be regulated by this handle, this next. It consists also of 3 electrodes one below this blue square, and the other two connected to this, connector, red connector. This one can be used, this sensor can be used to measure liquid and solid substances. And the other one can be used for orgone field radiated by hands or to measure liquids, immersed in liquids. And this one is for more accurate evaluations. Okay, next. This one is an example of a modified LM4 instrument. This one is the LM4, but set on this frame. And this sensor is moving up and down. So you can make a scan of the energy body of the organism. This one, of course, is used for human beings. Human beings or animals, but I don't see how easy it is to do this, to the scanning for to animals. But it's a mapping of the bioenergy field radiated by the organism, and is useful to locate areas of bioenergy blocks or probably diseases. Next. Some experiments. This one is an experiment using a leaf. The leaf, the bioenergy of the leaf was measured daily. Next. And next. For 9 consecutive days. Next. And the result is this. The radiation emitted by the orgone energy emitted by the leaf versus time was decreasing. It means that the leaf, freshly cut, observed a loss of vitality due to a gradual death of its cells. The author said that such a function might indicate the living system contains a bioenergy whose dissipation evidenced by a loss of vitality or orgone energy, bioenergy. It means that the dying of the cells of the human organs is a consequence of this decrease of bioenergy. So, hypothetically, if you are able to keep up, to maintain high the bioenergy level of the people, you never die. Simple. Okay, just the conclusion. The last one. Skip all. Okay, next one. Next time.
Wow.
Okay, just this one that is very interesting. Back.
Go to the graph.
Back. This one, using the instrument, the LM4, is reporting the bioenergy curve of a water measured by the blue square inside the vial versus the volume. The vial was increased in volume step by step, and the orgone energy radiated was measured. You see, that is the curve. This one is the orgone energy radiated, the field radiated by the biome water used, done by using a tuff, granular tuff, and the same water. The same basic water. You see that you observe an increase of energy of 130%. Last one, the last one. I have many other examples. The last one. Many examples. This one is an example of, okay, of the scanning, mapping, okay.
Maybe we can make